Kepler's laws. Newton showed that his law of gravitation leads to Kepler's empirical laws. 1. The law of orbits. All planets move in elliptical orbits with the sun at one focus. 2. The law of areas. A line that connects a planet to the sun sweeps out equal area in equal times. 3. The law of periods. The square of the periods of any planets is proportional to the cube of the semi-major axis of its orbit. This is a Kepler. Great. The law of orbit. All planets move in elliptical orbits with the sun at one focus. This is observation, okay? This is a elliptic. This is the sun at its focus. We know this is semi-major A. This is the focus, the C. C equal to EA, okay? A is a semi-major axis. E is eccentricity equal to C over A. Aphelion distance is A plus C, C equal to EA. Okay. Perihelion, this distance equal to A minus EA. Law of areas. A line that connects a planet to the sun sweeps out equal area in equal times. Oh, look at this one. It would sweep out equal area in equal time. Now let's check it. In this case, we see the gravitation force sun to the planet around the sun is tau equal to R cross F. This F is along the R, so this is the cross product to 0. Cross product 0. And this one, we write R times P equal to, that means it's linear momentum equal to constant, okay, from Newton's angular second law. What is air? Air is defined by R cross P. The magnitude of air, okay, this is a constant because this one. And this one matrix is RP perpendicular or PR perpendicular. This is P along the tangent. R, this is a P perpendicular. Go this way. This particular. What is P perpendicular? The P perpendicular means MV perpendicular. What is V perpendicular? V perpendicular is equal to omega R. This is V. V is omega R. And so this is equal to mR squared omega. It's constant. Now let's look at the area sweep there. In delta t, it moves delta theta. And this angle, we will see, this line is R, okay? This line is R. And this line is delta theta times R. And this triangle, the area of this triangle, the sweep out area, this angle is, we call it the base R then theta, multiple the height. The height is R, so and half. So the delta A equal to half R squared theta. And then we had the rate, change rate is divided by delta T. So dA dt equal to half R squared d theta dt over dt. D theta dt is omega, so that's equal to half R squared omega. And we see R squared omega equal to L over M. Okay, So that's why we prove this one. dA dt is the same as a constant. The law of periods. The square of the period of any planet is proportional to the cube of the semi-major axis of its orbit. We take circular motion as a sample. Okay, when he do the circular motion of the planet, this is gravitational force from the Earth. This is force actually is its centripetal force equal to m omega squared r. And omega is defined by 2 pi over t. You put the omega side, you get a t, and we get an r, and we found the relationship between t squared equal to 4 pi gm over m cancel r cubic. This is a circle. If this is a elliptical orbit, then we use the half major axis A. Replace it. This is A is a half major axis. So this is t squared over a cubic is a constant. Satellite, orbit, and energy. As a satellite orbits Earth on its elliptical path, both its speed, which fixes its kinetic energy, k, and its distance from the center of Earth, which fixes its gravitational potential energy, u, fluctuate with fixed periods. However, the mechanical energy E of the satellite remains constant. Here, the potential energy should belong to Earth and the satellite. But Earth is so big, so we can see all the kinetic energy is to the satellite. Potential energy is, as we know, that U equal to minus gm(r). This is the mass of sun, mass of a planet, the distance between that. And its kinetic energy, K could have mv squared. V is the speed of the planet. Look at the potential energy. Look at the kinetic energy, right? And we know that one, if the circular motion, this is gravitational force equal its centripetal forces, mv squared over r. With this equation, we cancel r, cancel m, we get mv squared equal to gmm over r. And the kinetic energy, we find half everyone, you get a half gm minus r. Okay? And if you see the u, this is equal to minus half u. And u. This is a k. This is u. How about this mechanical energy? Mechanical energy equal to k plus u. We put them together. You see, u is minus 2k. So the total energy equal to minus k, also equal to minus half u. This is a circular orbit. About the elliptical orbit, then we see we use the elliptical orbit, we use the semi-major axis of elliptical orbit, replace r. Sample. A playful astronomer relays a bowling ball of mass m 7.20 kilogram into a circular orbit about the Earth at an altitude h 350 kilometer. This is altitude. A. What is the mechanical energy E of the ball in this orbit? So the mechanical energy includes two parts, okay? Potential energy and kinetic energy, all right? We see the distance of this bowling ball to the center mass is 350 kilometer plus the radius of the Earth, 6,370. And this one we have to convert it into a meter. Okay, so this would be 6.72 times 10 to the 6 meter. Okay, well, this one will have potential energy. Okay, and we will have then total energy. We know the total energy equal to half U, right? Half U. So we put number inside, we get the number minus 214 megajoule. How come it is minus? Because we set the potential energy is 0 at infinity. Under that condition, it's a minus. B. What is the mechanical energy E0 of the ball on the launch pad at Cape Canaveral? From there to the orbit, what is the change delta E in the ball's mechanical energy? We want to find the BE0, and we can find the delta E. Okay, B0 because it's on the Earth, so we just very simple. We put everything inside. Okay, this is a constant. This is the mass of the Earth. This is the mass of the ball. This is distance. This distance is 360 miles above the Earth's surface. Okay, then we get the UOT. All right. Now, once you get this one, you get an E, because E has a relationship with U. Okay. Okay. At the launch pad, kinetic edge is 0, and this U is minus 4. So then the delta E equal to E minus E0. Okay. Minus 214 minus 451 is positive number 237. Einstein and gravitation. Okay. Principle of equivalence. We know Einstein, it has a general theory of relativity, and a fundamental postulate of the general theory of relativity about the gravitational is called the principle of equivalence. What is it? It sounds easy, which says the gravitation and the acceleration are equivalent. Curvature of space. We have thus far explained gravitational force as due to the force between the masses. And Einstein have different explanation. Einstein shows that instead, gravitational force is due to a curvature or shape of space that is caused by the mass. This is very complicated, but it has been proved by the experiment. Okay. Now, we find out the light from a distance quasar, very bright light, follows past curved paths around a galaxy or large black hole, because of the very heavy masses that the light would twit. Okay, this has been proved